So now that we're done learning about functions and then doing algebra and composition of functions, we're kind of going to go back to like the pictures of functions and how do we describe or talk about some of the features of a function. And then finally, we're going to graph transformations of functions. So this next lesson is on symmetry. In math, we are going to talk about having three types of symmetry. We will have x-axis symmetry, y-axis symmetry, and origin symmetry. There's lots more symmetry, but these are just the three we talk about here. X-axis of symmetry is that if you have a point up here, something like 2, 3, you will have a point down here at 2, -3. What happened? Well, to be symmetric about the x-axis, every point that is above the x-axis will exist below the x-axis. So to test for x-axis symmetry, you replace a y with a negative y and make sure you get the same x value. Does that make sense? Right? So it doesn't matter whether I put in 3 or -3, you are going to have an x value of 2. Whereas y-axis symmetry, to be symmetric about the y-axis, if you have a point over here at -3, 12, then you'll have a point across the y-axis at 3, 12. So to test for y-axis symmetry, you could replace x with -x and make sure you get the same y value. And then lastly, we have origin symmetry. That means you're symmetric about the origin, so you can be in quadrant 1 and then in quadrant 3, or quadrant 2 and quadrant 4. But what it is that if you have a point like 3, 2, you'd have a point at -3, -2. Or if you had a point at -3, 2, you'd have a point at 3, -2. So to test for it, you replace the x with -x and the y with -y and make sure that you get the same function values. So what we're going to do is we're going to just test these three. We are determining if these graphs are symmetrical with respect to the x-axis, y-axis, or origin, and we're going to test that algebraically. So looking at this first graph, can you tell? What kind of symmetry do we think this graph has? Well, because it's across the x-axis, we're going to call this x-axis symmetry. To test for x-axis symmetry, you replace y with -y. So in that equation, you're going to put in for y, you're going to replace it with a -y. And then you're going to simplify. So -y squared is y squared equals x minus 1. And then you check, is this equation equivalent to this equation? Yes, there is x-axis symmetry. Now, if you tested for anything else, so if you tested for y-axis symmetry or origin symmetry, it would fail. So for example, if you were testing for y-axis symmetry, just out of curiosity, right, you would replace x with -x. When you do that, you get y squared equals -x minus 1. This is a completely different function than this one, so it would fail the y-axis symmetry. This one, what are we going to test? Well, because it's across the y-axis, I just noticed that this graph's been put in backwards. I should flip it back over, but it doesn't matter because it has y-axis symmetry. So to test for y-axis symmetry, you replace x with -x. So what's that going to look like? Well, in this equation, you've got y equals -x squared plus 2. And then -x squared is x squared plus 2. And then you check, is it the same? Yeah, so it passes the y-axis symmetry test. And if you tested for x-axis symmetry, so replacing y with -y, or origin symmetry, it would fail. The next one we're going to look at is this one. We want to test what kind of symmetry. Well, it's not across the x-axis, it's not across the y-axis. This one we're going to be testing for origin symmetry. To test for origin symmetry, you replace x with -x and y with -y. If you look at this one, we're going to replace y with -y. We're going to replace x with -x. But this one, in order to test, you have to make sure it's y equals. So we're going to multiply or divide by -1. Let's just divide everything by -1, and we'd end up with y equals 1 over x. So it passes origin symmetry. If you just did x-axis symmetry or just y-axis symmetry, it would fail. Now, just a note of caution, when you do your homework, they don't give you the picture. So you actually have to test all three if you're not sure which one it is. So really, I just wanted to show you each of them passing. But really, if it was a test and it said test algebraically for symmetry, you would test x-axis, y-axis, origin for all three of these. But I'll only ask you for one and not a whole bunch.